Hello, welcome to fourth episode in our series, and let's continue. In this lesson, we will create another small HDA, very simple, to appraise this terrain, and then we will jump directly to pipeline and merge both branch together. So in this lesson, we will create our final terrain partitioner. So let's go inside sub HDA, create another subnetwork. We'll create actual sample, basic resolution, grid spacing 1, blur, blur is enough. That's it. It's very simple. Create digital asset, press border, drain, press border, HDA, create, apply, accept, drain pipeline, processor, select the press border, or services, HDA, file inputs. In last episode, uh, I wrote it that we need to solve the problem that Houdini cannot find our files. So after some trials, I found a solution. If we put the tag file slash something else, it will work. So file slash geo works. So we can copy file slash process terrain, file process terrain, file process terrain, file process terrain, file process terrain. So okay, so we can check the PTT services. Okay, we start manually, so we can see that everything works smoothly. Service is ready. Click on this node. Okay. Now if we jump here, delete node, as we can see, if you select the first one, geometry import, we can see that Houdini automatically find everything what is behind, so it automatically delete every file what is below the network. So it's perfectly fine, because if you made some change in the train prepare here, automatically everything is marked as obsolete. So accept to delete everything, and you can rename it press order EDG index 8000. Again, let's take up this note. We can check EDG visualization. Now we have perfectly fine rain. Now, if we look at the at this left side, you now see that it not match perfectly. So that's why we have our terrain slicks to overlap each other, so we will smoothly adapt the terrain. Mm. So let's say you have a situation. Let's say you have situation and you have some terrain, and you need to find all adjacent cell or cell which is in a particular area. Like, I have this terrain, I need to find these cells. I have this terrain, I need to find these cells. One solution is using a partitioner bound, but it will be complex because it need to open the geometry, find bounding box, and so on. Another approach is using attributes, because it is cell. We have information, okay, in that this terrain is the first row, the second column. So we need to find the first all terrains in the first row, and maybe zero row if there is any, and the second row, and the zero column, and the second column. I change the desktop to tops, so we are in the task context. uh, jump inside the network graph and start a simple generic generator. Uh, simple 10 items. Create one integer, name it x, and value put a ptg index. Okay, we have our x 0 to 9. Which node? 15 wedges, which attribute will be y. Copy parameter relative reference -1. So we have now 150 work items. And what is specifically here? This wedge node automatically create a wedge index attribute, which is unique for each item. So we will do now. We will split, or we will make 2 copies. Now we need to find to this cell what has coordinates 0 and 1 corresponding cells which are around this cell. So if I select this one, so we need to find for this cell as our source each cell which coordinate x is 3 or 5 and y is 12 or 14 or between. Partition by node. We will combine. This. We will sort it by index because we will merge the attributes and we will append them to array. So we have now the pair of attributes. You can see that we have different values here. So we can filter expression. We can keep attribute first array minus x, the second value in array, and absolute value to be less than 2. We can add another one, absolute value of y. We will create integer attributes, result, and value will be 1. And now we can put another partition, and it will be the partitioner by comparison. So we can compare the source and the destination according to this result. So what's this sort contains input to order? So first one, and what this now to do? It looks for attribute which will be which index, and per attribute. So it will look which index is 0, which index is 0, and if the which index is 0, the which second is 0, and the result is 1, it will match it together. So now we have 150 algorithms, and it's a source and 4 destination. Source and 6 destination. Last one, source and 4 destination is this last one, and 1, 2, 3, 4, 4 cells around. So it perfectly works on this. And because when we set a sort context to input node order, we can be sure that the first work item will be always outsourced. We can now use this one in uh, our example. In this node, uh, we have two outputs. So we will connect the first here, the second will be here. And we can, if we check, for example, if you put now here, dirty cook, uh, we need to specify which one. because we don't have two outputs here, as we expected in a subcontext. We need to specify directly that we will use the second one, and we can do it simply using because this first file partitioner, the second file the file geo. Play this one. Use geometry import node. Space here. And we specify that want we we need this one geometry out files with this type, and we will store it in attribute process array. Also, we need to extract some data, so we need to extract our column position, our row position. Same will be here. In this case, we will just file geo, and we will call the attribute name empty empty train. So now geometry lies in this attribute. There's no outputs, only inputs. We have plenty of attributes here, so we can reduce. We'll rename this one output tag empty train. Empty train. Source destination. So we can now just simply connect partition by node And now we need to compare this one, this one. So we need to change because the sourcer will be the bigger one inside, and this is processed terrain. So this is the cells around the selected terrain. So get info from destination and source. Perfect. Make sure that sort context is by input node. So our destination is at the first geometry. Now I put two geometry imports nodes. So attribute just terrain. And here will be empty terrain. Empty terrain is one tile, process terrain, and import merge all geometry together. Expand partitioner. Here we will create the integer attribute on primitive. And see that our processed terrain is one file. So we can check our site on PDG visualization. It's our terrain for cells. 6 cells made together. Now we can see that in this area we will merge them together. We know that we have our ramp. If we can see isolate layer, we set merge mask. We have our merge mask inside. So perfect. So that's for this lesson. We can clean it here, merge it together here. We can merge it. Why? Okay, so I have it is nice icon here. Can partition my node in this time. Now for empty train and process terrain. Empty terrain tag file process terrain tag. So in the next lesson, we will create a new HDA where we will combine the terrain together.